According to the color bands, this resistor is 12 meg, which is higher than the maximum 9.999 meg this meter will read, thus the out-of-range result. But there's still a way to test the value of this resistor. Here's an equation for determining the total resistance of two resistors in parallel, or this version if you prefer. What this means is that the resistance of the two resistors in parallel is guaranteed to be less than the least value resistor. So, if I put in parallel a resistor that the meter can read, the total resistance will also be readable. I'll use the 5.338 meg resistor. It now reads 3.748 meg. Rearranging the previous equations gives these equations. Use whichever form you prefer. The value of the unknown resistor is 12.583 meg. It's probably not a perfect method, since it's probably compounding measurement inaccuracies, but it's certainly close enough. By the way, remember to consider unit prefixes when doing this calculation. Both these resistors are in the same unit prefix, as a result, all megaohms, so no problem. But if one was kiloohms, for example, care should be taken in doing the calculations. By the way, you can do the same with capacitors. However, since capacitors in series and parallel work the opposite of resistors in series and parallel, you now would use capacitors in series. And the equations are similar. If either capacitor is polarized, observe polarity when connecting everything up. Please subscribe, like, share, comment, etc. And if you click subscribe, click the bell to receive notifications of future videos.